Good afternoon, guys. Uh, Today is was a vacation here in Germany, so we enjoyed a free day, and now I'm ready and excited to do some JavaScript coding. Uh, I discovered a few minutes ago that actually today is the Apple's keynote, and I for some reason thought it's on Tuesday. I thought it's always on Tuesdays, but thanks for joining. Maybe you can look at both at the same time, but just don't tell me what are the news in Apple because I will watch that afterwards or maybe tomorrow. So don't spoil it for me. I'm Robin and I do functional JavaScript solution for Katas. Kata is a small task in JavaScript that should keep you sharp and ready for your everyday tasks. I use this site called Recursive, where they have really nice tasks and they provide ability to browse the solutions of other people, which we do. We look how other people do it, we comment on that, or we look how else could it be done. I try to write in functional JavaScript. I was thinking about maybe explaining that a bit into depth because some people ask me what I mean by functional. For now, I want to say that I want structures that are immutable. That means you can't easily change them. I rely on functions instead of classes, for example. And I work a lot with arrays, and I use map, filter, and reduce. That's the name of the stream today, because these three things together provide a really powerful triplet how to solve all the problems. Okay, most of the problems we encounter. Okay, if you want to know how it works, I will start. I want to tell you, I really want you to write in the chat, ask, suggest, and just communicate if you want something. I really like that. I'm really bad at naming things, so if you think you can name it better, just write me. If you think I have some mistake, just write me. I think it's best when you also write something to me. The last time we did the crypto, I think the last, exorcism, fetch. So I'm doing the ECMAScript track, and this will get me the next task to work on. And this one is called Luhn. Interesting. So I will open it here. It's here. I open the README, I open the spec, and I also create a new file so we don't spend much time with it afterwards, and I can close the tree view. Right, Luhn. Given a number, determine whether or not it is a valid per the Luhn formula. The Luhn algorithm is a simple checksum formula used to validate a variety of identifications, numbers such as credit card numbers or Canadian social insurance numbers. Okay, yeah, that's the well-known algorithm to check if a credit card, if the numbers can be a credit card numbers. That's a nice one. If a given string is valid. Yes, very cool. So how it goes, strings of length 1 or less are not valid. Spaces are not allowed, but they should be stripped, okay? All other non-digit characters are disallowed. The first step is to double every second digit, starting from the right. Okay, here, okay. If doubling the number results in a number greater than 9, then we subtract 9 from the product, okay. So we do this, we have this, and then we sum all of the digits. If the sum is evenly divisible by 10, then the number is valid. This number is valid because it's 80. Yeah, very cool. This is example. Okay, I think this could be really nice. This could be really interesting, and I think this is exactly where we'll use all the functional array methods I told you at the beginning. Let's look at the test so we are sure. So again, they want us to use classes, which we don't like. We don't like classes, and it's just urgent and valid or whatever. So the API is we have the Luhn method, we pass it a string, and we expect valid is either false or true. This one is valid. Yeah, this one is not. Okay. and if it doesn't have okay, that is cool. That is cool, I think. Okay, so we can start writing. We export and a function, and we will receive the input here, and the API forces us to use this really weird thing when we return an object, and that object has a property called valid, and that's either true or not. So this is actually a valid program. I will run a watch task, so we see how we progress with those. Yeah, we pass it, but it's just that's not what we want to do. So I think we have like two separate things. The first one is we check if the input is valid in the sense of the characters. So that means that it does not include anything else than a space. If it does, it's automatically invalid. If it doesn't, we remove those spaces, and we will pass this to the function that will work only like with sanitized input. Okay, I think that's what we want to do. I'm thinking how we should do that. I will actually add this here because this will be a little bit longer. I mean, it will not do much things, so it's kind of okay. I will create a first variable, which would be has invalid character, which we will somehow get. For now, I will write false. And then if this is actually true, we will return this object, which just says false here. If not, we okay, yeah, I guess we return this object, and on this place we run a function called is valid for that input. Maybe we will change it as we proceed. So we have these two things. The first one I will probably start is that I will authenticate the specs. Okay, I see that. So first thing would be here that I would do const sanitize. Is it how you spell it? I hope so. I always like I'm not sure about spelling these words. Yeah, that looks good. So this is the sanitized, and it's actually the input where we replace all the spaces with nothing. And that's what we will pass into this function, and I'm going to write the function is valid. So it receives an input, and what we do first, we turn this string into an array. This is how we do it, like each character is in like character by character, and then we will go, but we will go like every second from the back. That means it will be easy to reverse the array, which is like it's okay, we can reverse it, it doesn't change anything. But now every element with even index, because we start with 0, we double it, right? So now we can write a function. Oh, first we should turn it into integers, right? So this will turn it into an array of integers. Then I can say double every second. Well, it's kind of weird naming, but we will have that. After that, we can like sum it, if I remember that. Let me go here. What do we do? Where is it? Double every second digit. Yeah, and then we do this thing. Then we sum of all it, and we look if it's divisible by 10. So we do this sum, which returns yeah, it returns a number, and we will check if it's divisible by 10. That's how we check this right here. I kind of not sure if I like this producing one thing and then this is the next, but I think right now we can have it, and we will see how we like it later. Now we need to implement this double every second. That's not that difficult, I guess. So it receives a number. Oh, sorry, number and index. What we do here is that we look if the index is even, and I want to write this like really properly. So I write here is equal to 0. So that means if this is equal to 0, then we just return the n. Oh, what is this? And if not, it means it's the every second from the right. What we do is we double it, but we also need to make sure that it is not bigger than 10. So I assume we will write a new function, which would be double and, okay, double and, how do you call that? That's the naming I was talking about. Double and, let's call it cat, I don't know, maybe that's a good name for n. This function double and cat now only receives one number, and what we return. So if n is bigger than 4, right? Because then the double would be 10 or more. I think this should be, how is that? If it's, yeah, is greater than 9, it means that the original one was bigger than 4. So if it's bigger than 4, we return n times 2 minus 9. Otherwise, we return n times 2. That's cool. We save it. Oh, we have some problem. A sum is not defined. Yeah, sure. We need to define function sum. I think I wrote it here like 100 times already. So this is a function for the reduce. It receives pref and next, and the only thing it does, it just sums these together, pref plus next. Very cool. Save. We have a problem. Okay, what is this? We got one. Oh yeah, because we received this. Okay, I see that equals 0. We save it where we are. Run all. Yeah, we passed that. That's okay. For this one, I'm not sure because, yeah, it says that a single 0 is invalid. Maybe I would do that in this has invalid character. I'm not sure. We can maybe check the size of that. The problem here is that, of course, I would kind of skip this one and do it later when we have better understanding what was happening. So if this one, we save it, and oh, it fails. Interesting. So we do something wrong. That's going to be fun now. So I assume, let's see, what is the sum? It's 41, which is not divisible by 10. And we can write it out, or no, maybe, okay, I see that. We can return the array without being summed, and we can see all the digits and compare them how they should be. So the first one is 7 times 2 is 14 minus 9. That should be 15, 5, right? Okay, I maybe did something wrong. 8 times 2 is 16, minus 9 is actually 7. Yeah, it's good. Oh, sorry. Oh, yeah, yeah. Yeah, why is this one changed? I see that. Why is number 7 changed? Should be there as it is. And okay, we do something really wrong here. We changed the. Oh, okay. I'm looking at these. My bad. So I'm looking at this, right? So we have 6 times 2. Oh yeah, we don't double it. 8 times 2 is 16, minus 9 is 7. Cool. 2 is as it is. And then we have this 8. If we have this number 4, it should be double. It's 8. Oh, it should be just simply doubled, but now it's 0. How could it be 0? Okay, let me see. So double and cut. So if n is bigger than, okay, I see it. Should I do it like this? I still get 0. Where do I get a 0? How do I get a 0? I don't see that. I don't see the 0. And then this 5 should be 1. Oh, I cannot see that. And then, so we have this extra 0 here. How is that? It seems that this space is not getting, like it's being turned into a number, which should not definitely happen, right? Because here we replace, okay, we can do it with like any, wow, this is weird. Oh yeah, I'm not sure how we get the 0 here. It looks like we get the 0 from this space. I'm not sure. This should work, right? I mean, I write a space here, so that should definitely work. What I will do is that I will try to remove this space, and I want to see. Oh yeah, that's how it should be, right? So we have problem that if I remove those spaces, it looks a little bit different. So okay, I will like this. We still have it failed. Receive. Oh, sorry. As I wrote before, yeah. So we have problems with spaces. I don't know how is it possible. I'll put this. Yeah. Okay. So spaces. Is this? Yeah, it should work, right? Replace something with what? I will look at the documentation. But that should definitely work, right? That's how it works. Oh, I know what is the problem. It only removes the first. Now it should remove all of them, right? Oh, only the first. I see that. Okay, that is bad. Okay, my bad. I thought it replaces all of them. So we want to replace all this white space globally on the string. Save it. Yeah, it works. Okay, I was stupid. We have the next one, which should be invalid. It is. We have a credit card. It is valid, and this one right now will. Okay, I don't know how that works. Not really sure how it works. There's something wrong with this because this should like be checked. It doesn't include anything that numbers. I don't know. So I'm not sure how that. Can I change this to like 7 and see if it still passes? That is weird. I don't know how it happens. It's weird. I did not implement that function, so I don't know how it works. And then we have the problem with the 0. This shouldn't be working. I mean, this one should not definitely be working. How is it possible it's working? It still works. Okay, but it's weird. I don't understand that. That's kind of funny. I don't know how it works. I would change this. I would call it is valid format, right? And there will be something different because that can also check the length of that. So I will do that, has valid format, and I will write it, for example, here, has valid format, and it receives the input. And what we do with this input is we will actually check two conditions. So I will write it in this function. It's if input dot length is greater, oh no, it's smaller than 2, we return false. And then what we do is that we need to check it, otherwise we will write this regular expression, and the regular expression is 0 till 9, or a space, multiple time, right? Or whatever. I mean, we already know it's more of that. And then it goes from the beginning to the end, and we can test the input. Let's save it, and we will see. Okay. That's interesting. It changed the Canadian's SIN for the valid one. How the hell is it possible? Okay, today is really weird. I don't know why these things don't work, and if they don't work, it's weird. So we have valid format input, right? Oh, if it is not valid format, right? And here we test it, but we actually, oh no, we can do something better. Okay, so we test if there's something else than this. It still looks weird on the Canadian SIN. I'm not sure, does the space have to be like this? I don't know, maybe I can write like this. I don't know, what is happening here? What is happening here? Okay, I think we will have to, oh, now it should work, we have a regular expression, just anything, if there's anything beside this, in this input, return true, and we don't want that, right? We want to actually this, which is, okay, how it works. That is kind of weird, isn't it? And that should also work for this skipped case we had, and it does. So let me go through that again. We have this default function, it receives the input. Now it's actually maybe a good, no, let's keep it as it is. Now, what I will do is that I will create a let variable. It means we will override it. I don't like this, but I guess it's probably a good idea to do that. And I will call it valid. And by default, we say that it is valid. Like the whole thing is valid. If it's not valid format, what we will do is we will. No, we shouldn't do that. No, let's go back. I like that one. This is good. This is good as it is. We check the format. If it's bad, we return this thing. If it's then we sanitize it, replacing all the spaces, and we run this function is valid, which is kind of nice. Just takes the input, puts it into arrays, reverse that, maps to numbers, doubles every second, sums it, and then it kind of checks if it's divisible by 10. Maybe this could have been done a little bit better, because it's not clear, like, but I mean, yeah, it is. I kind of like that. Yeah, I like that. I would keep it. Double every second is this. Double and cut. Well, we can actually change that, right? As I see it, I'm not sure how it's possible. I haven't seen it at the beginning. We always double it, and then we add. Oh, sorry, we subtract either 9 or 0, right? I guess this is like a little bit better, so here we check how it works. Save it, yeah, we go through. Hi Kochi, thanks for joining. Yeah, I think this is good. Quickly looking at that, I see that, yeah, we can change this. We have two conditions, so we should think about it positively. So true means it's bigger than 1. So we will have these two conditions. Oh shit. Yeah, so we have these two positive conditions and both of them need to be true. It needs to be bigger than 1, and then this test must not, like, it should not match anything than digits and space. Cool. We have that as a special. Yes, I like that. Yeah, okay. I don't like this like API, but it's what the tests force us to do. Okay, so in that, let's submit that. Submit Luhn.js. Come on, yeah, we have it here. So I'm copying that. I will show it here. Okay. Yeah, it's correct, and I will post it into the chat so you can see it as well. Yeah, so that's our solution, and let's see our implementations in. Yeah, sorry. So we always good at this guy, I don't know why. And then we can maybe look, oh, 4 iterations, that could be interesting. Let's see if we learn something here. So this first guy, I think it's clearly visible. So yeah, he uses the class as kind of it wanted. We have num, and then is valid, he uses the get, has good approach. So first, if it includes something else, return false. Then if after replacing, oh, that's interesting, the length is smaller to return false. Yeah, this will take care of the spaces of the length, and it also takes care about other characters like the A's and B's and whatever. And then he replaces, oh, it's kind of weird, I mean, he already did that, right? But whatever, he splits that, reverse that, and then he, oh, so this is the sum, but it's kind of difficult to see that because it's, yeah, it's first it's written kind of weirdly. Like, I mean, this, it could be just P plus C, but he points it, but yeah, okay, that's weird. That is weird. It's definitely weird, and this equals should not be there. And then, could someone tell me, like, by seeing that at the first time, if they would understand what this means? Because I would not. Like, it's like two, it's called ternary operators, and some weird constants in here, right? So you have, if it's, oh yeah, if it's the index is even, right? Then return C times 1. Why do you times it by 1, okay? Otherwise, it's C times 2. And by the way, here we have, oh, I see that. Oh, okay, now I see what is this. It's totally not readable, Hohit, yeah. And this C times 1 turns the C, which is now a string, into a number. That's nasty. That's really nasty. You shouldn't do that. And here we have this. If C times 2 is bigger than 9, then C times 2 minus 2, yeah, that's what we did. Yeah, okay. Interesting. I definitely dislike this. I mean, this line makes it so bad. That's not a good solution because of this line. If it was written differently, it could have been a good solution. Yeah. Yeah, I don't like it either. I don't like it either. What do we have next? So this one is oh yeah, but nothing. I would say nothing important. These I'm going through all the iterations this person wrote. Okay, but it seems that's nothing important. So first one, okay. So what we do? Oh, he says the valid in the constructor. That's kind of good, I guess. Here we replace a space written like this, interesting, with nothing. Okay, that's good. I mean, you kind of remove the spaces and you can like look at the rest. I kind of like that. That's a good approach. You split it. You map it to numbers, which I'm not sure that's actually correct, because in the previous we've seen that it could be like letters and we don't check for that, but maybe it's not needed, I don't know. And then, yeah, we check if the index is again, even. If yes, we return the number. If not, yeah, it's the same thing. But I mean, again, this is not very nice. This is a little bit better. We don't need a 0 for this, but it's maybe good practice to use that. Oh, and we do this. Oh, this is not good. And then we check this. These operations should be done in the exact opposite, because if this number, oh yeah, whatever, but you have to go through all of these functions uselessly because you already know and you wouldn't use that. Yeah, I mean, this is really bad. Kochi writes that this should be like a white space. We don't need that plus. We just need the white space as we have it here. It will replace it because we have the G there. So the plus is kind of, I mean, this is the same thing as plus E or whatever. Yeah, but I mean, this is weird. And even though, I mean, you can't be sure this is actually a space. It could be any other character. I mean, if it was a tab, it could have looked similar. I don't know. Okay, cool, interesting. Yeah, who is writing? Is this a contest of who's giving the longest one-line solution? I kind of think so. Yeah, you can do that. I guess people want to do that. I mean, it's kind of fun to write one-liners somehow, even though, I don't know, like it can be interesting, but then you go through it and you don't know what happened. Oh, pick Latin. That's gonna be interesting. Pick Latin. I think I heard that. It's like you try to speak. You change, like you speak somehow, but you change it so it sounds like Latin, but it's not. We will see. New file. Okay, let me create everything. So we are ready to go. Close this and go to README. Yeah, Coach, you are exactly right. It can be, I don't know, I don't like the solution either. Pick Latin. Implement a program that translates from English to Pick Latin. Pick Latin is a made-up children's language that's intended to be confusing. It obeys a few simple rules, but when it's spoken quickly, it's really difficult for non-children and non-native speakers to understand. Okay. Rule number 1. If a word begins with a vowel sound, that's important, add an A sound to the end of the word. Rule 2, if a word begins with a consonant, sorry, something's happening to me. Sorry, my bad. If a word begins with a consonant sound, move it to the end of the word and then add a sound to the end of the word. So you always add the a sound. Is it how it works? Is it how it works? I don't know. There are a few more rules for edge cases, and there are regional variants too. Okay, we have some Wikipedia page for that. Oh, I have some problem here. Okay, that seems to be all. Let's see what I have in the specification. It translates a word beginning with A. Yeah, so you have apple and you add A. Oh, I need to. Something happened with my second display. I hate this. Sorry about this. I can't see your chat now, you know, that's the problem. Okay, whatever. Guess we don't need that. Let's go quickly. I will shut on there. Okay. I don't know, maybe we'll reconnect, hopefully. We have ear, and we do array. Okay, pick. Oh yeah, that's when it starts with P, so we put a P at the end and add A. Koala, chair, queen, square, array P, trash, that's the same, school, quick, fast, run. I'm not sure how it would work with like a knife or something like that. Oh no, a knife is okay. Yeah, maybe okay, cool. We'll see. So I mean, this is kind of easy. So we take, yeah, again, we have this. I don't know why we have this API we translate. I don't like that. I don't think we need that. But I don't know. That's people just. I mean, this. It's like the only thing I don't like about Exercism is that they make you use this API, and I definitely don't like it. Like, really much don't like it. Yeah, I don't know what's happening. I can maybe like try to quit this. Okay, didn't want that. I hope you still see me. Yeah, it doesn't work. I don't know. So, oh yeah, it works now. Cool, cool. Everything should be working now. That's cool. My bad. Sorry. This should be kind of easy, right? We just take the word, take the first letter. I mean, yeah, let's go. Let's just write it. Export default. We have to write this rather stupid thing. Yeah, that's how. That's the API. I'm sorry about that. But we write this method translate. It receives, how we call it. Let's call it input. I'm not good at this. You take input, and then, oh yeah, you don't take the input. We actually take it in the first and then tail, right? First and, oh, this is not a space. So this will take the first letter of that word. This will take the rest of it. And now what we will do is that here we write something like is vowel. Oh no, we will do it differently. Yeah. So we will create a set. That's the trick here. So we create a set calls vowels, and that's a set of all the vowels there are. Like this. Yeah, that's it. That's cool. So this is a set. The set will split this into like individual letters, and then what we can do is we can do vowels has the first letter, and if it does, we take the tail. I forgot about that. Or we just append a. Okay. So we just do first and then tail, so we don't change anything, right? Join it and add, maybe we can change that, A. Is it A? Yeah, A. Okay, cool. Otherwise, we take tail and then first, and we do the same. So that means we can later refactor this to be nicer, but this should work now. Oh yeah, I need to run all. First is not defined. I hate this. So oh, what? First is not defined. That's the error we get. first translate apple. This should definitely work. It kind of means our console login will see. Oh, I forgot to write it's a function. That's bad. Yeah, and now I did this. Okay, cool. Reverting, everything's back. Expected to be equal to app play, received app play. Why is that? We join it with empty string here. Why is that? Yeah, thank you. Orem, yeah, now I see that. How do we get these commas in there? Oh, of course we need to spread this. I don't know how I forgot about that. Yeah, sure. Now it works. Cool. That is cool. We can change that a little bit later, I guess. Let's go. Let's enable these. It goes. Oh man, maybe I can I'm kind of, oh. Chair, okay. Chair. Okay. It says that the chairs should be there. Okay, I will disable this and we will go with the rest of those. And okay, this is gonna be more difficult, I see. I see that. Okay, square. Again, like these, some of those together, like square, should be like taken together. Okay, that will definitely make it a little bit more difficult. I didn't see at the first. Okay. Mm-hmm. I haven't thought about it. Okay. So what I actually want to do is that so the problem is it can be like first one or first two or even first three or even first three, that's the same. I guess we will have to use the begins with. Okay, I think it's gonna be more important. Like this, what we do here is kind of good. So this branch is kind of okay, but this branch, meaning does not have a vowel, is wrong because this first can be longer. So we would have to. I guess we have to create a function that takes these, like, yeah. Yeah, I think so. This is gonna be a little bit more work, unfortunately. So I will write it like this. And this is where we return. And take this input, put it here. Yeah, we have still the same problem. That's cool. And now, instead of like writing like this, I kind of assume I should write this a function that splits it into like first and tail, but this first can be something more. So yeah, let's take the function. How to name it? Let's just call it split. I mean, I'm not good at naming. And it will return two arrays. It's like the first part. I will then call it head and tail, and we don't have to spread it here, so it will be head. Oh, I just want to write it like this, right? Head, tail. And again, maybe we can later refactor this whole. Oh, I can't write. Oh, what is happening? So this is tail, head. This is head, tail. Okay, that was good. Okay, I can do that, right? So I will do it like this again. It's still good for refactoring. Oh, we can do this, right? That's cool. Still good for refactoring, but we probably can get there. Split, yeah, split on define, of course. We haven't written that. Const split. So it receives, let's call it still input, right? And now it's gonna be a little bit difficult. So what we need to do is we should write a set, I guess, again, a set of those beginnings, right? Where is it? Yeah, trash, school. And then we would check if any of these are at the beginning of that. And if they are, we split it like this. If they are not, we kind of go back to the vowels we have here. Oh, we don't have, no, sorry. And then we take the first letter otherwise. Yeah, I see that, okay. Okay. And we need to maintain the order, because if it starts with THR, it will also start with TH, but we want to first check this one, so it needs to go in order from the longer ones to the substrings of those. So let's call it, how do we call that? It's important. Yeah, I'm not sure how these are called in English, like these syllables. Is this a syllable, something like that? Maybe it's a syllable. It's like one sound. Yeah, let's call it like sounds. It's maybe a bad naming, but I can't find better ones. And what we have there, and I will enable those, it would be, let's enable all of those. Queen. We have skew. That's interesting. This could be this skew, and then q. Okay, we'll try that. So we have skew, and then q, and then where is that? THR, THR, and just TH. Okay, so we go like this. Sorry. And if we find something that matches, we want that, right? So now it's the important thing is to go for the array and first check if something matches, and then get it. So there are multiple ways how to do that. We can use array find, because I think it tries to find it. It's the first one, it goes and returns the first element that satisfies the predicate. That's exactly what we want, and I just want to make sure, yeah, otherwise it returns undefined. That's exactly what we want, that's exactly what we want. So what we do is that we take, we need to name it, right? So it's, let's call it sound, I don't know. And it's gonna be sounds.find, and we receive s, and we want that input. Oh, we're in JavaScript 6, right? So we could use the string. Oh, my bad. We can use the string begins with. I think it's begins with, right? It's kind of a new one. It's definitely not available in, can I see all the methods somewhere? Yeah. Yeah, starts with. I bet it is, but it should be implemented in the version of Node I'm using. So it starts with this S. And then what we do, if we have sound, right, we return the sound. If we don't have it, we return, oh no, my bad. Whatever, this is like the first one, right? So we return the first letter of those. The problem here, yeah, is that we said we should, yeah, that's bad. So we need to change it. So if we have sound, we have to return an array. The first one is the sound, the rest is the input, where we like kind of remove from the beginning. I'm not sure if replace is good here. I always like, maybe there's a better method, like remove from the beginning. Is that something like that? It's like replace makes sense, right? But it's something like starts with no, pet start, no, okay, we need to, I would say replace is good. So you want to replace sound with nothing, right? And let me format that a little bit better. And then, if not, we kind of want to do the thing I did previously, right? Yeah, I guess I have to write it like this, I don't know. And then we do input, and then is substring. I hope it's like that. I'll always mix them up, but I hope it's like substring 1. I want to see that. I always get the it's a dot substring. Yeah, okay. I'm not sure. I always mix these up. Start, yeah, that's what I want. Between 1, yeah. Optional, yeah, that's what we want. We want to start with substring 1. That should be it. Oh yeah. And it works now. Cool. What is splice? Oh, splice. Yeah. Can we use splice here? It's not an array now. We haven't used it as an array. We have it, okay. Splice, what is better? What is the difference? Slice. Oh, you would splice. I think we don't have splice, right? No, but here's, I'm not sure what is the difference between slice, substring, and substitutor. Oh yeah, I see. Substitutor is start and length. Substring is start and end. Okay, and then slice is start and end. But it works for negative. Okay. Yeah. I mean, yeah, I would also like to use arrays. I like them much more, but I can't. I mean, this is difficult to do with arrays. Like if you have a non-deterministic number of first letters. Yeah. I mean, this function. I mean, I'm not extremely happy about this function, to be honest. It's too much. I don't like that. It's too much, I don't know how to say that, like too much string manipulation, right? I will actually write that. So if we have sound, then we will return this thing. This is the first one. I think that's kind of understandable what it does. If we don't have it, yeah, we will do this thing I had there before. So I will have it const head and tail, but the tail is taken like this, is the input, and we return, here is head, here is tail. I mean, yeah, I kind of like this more. It's more readable. You know what's happening. This is head, this is tail, so that's good. Yeah, that's a little bit better. Let's go next. Oh yeah, I want to do this CH. This should fail now because I don't have it in my sounds. That was not good. Now it passes, and there's still okay. So everyone should be one of the first ones. It can be here, I guess. And we have, that's it. Oh, okay. What is this? Why we have school taken as, did I copy that? SH, what is this? Oh yeah, it works. I just didn't save it, I guess. And translates a phrase. I don't know that. Okay. But it's okay. That's cool because this function kind of like translates words, right? So what I will do is that I will copy this line, move it. How do I move here? Yeah, like this. Move it here. This one is actually translate word. That's kind of cool. So what we do here is that we take input. We split it by, I guess we can split it, I mean the best would be to split it by white space, just to be sure. Then we map each with translate word, and then we join it with a space. Save. No, something's wrong. Join is, oh yeah, dot join. It works. Okay, MathG says that he solved this somehow without saving consonants. You mean like these consonants, like these sounds? Is that what you mean? I'm not sure it's achievable. I mean, otherwise, like, I mean, maybe it is, I don't know. Is it possible to say that SQU is like one thing together? I mean, technically speaking, we could have taken these and put them here, right? It would work the same. Because if it starts with that, so, okay, I mean, I can go back to the tasks. And the task here is that, like, if it starts with a consonant like K, you just put it to the back. But if it's a sound like CH, like chair, you want to put this whole sound of ch to the end. I kind of failed to see how else could that be done. What I think that actually could work is that I would take this out and write it here as individual letters. That way I can somehow, no I can't, sorry, no, my bad, I can't do that, that's bad. We need to go back, whatever, sorry. Constant is not a vowel. I would say that's exactly the definition of it, isn't it? I guess we have to like save these special SQU, TH, and THR. The trick is to write them in this order, right? So THR has to go before TH. Maybe it's actually a good thing to put them in an alphabetical order. Like this. Oh, but yeah, with these. I I kind of fail to see how else could that be done, but maybe we will see that soon. So let me go through that and see what we can like change. So first is a translate, which takes the input, splits it with space, translates each word and joins it with space. That's what we want. And we have the word translate word method, takes input, uses this split function, which returns head and tail. And then if the head is a vowel, I will post it soon, the link. Head, tail. So I will take this is not good, and put it into a different const. I'm not sure how that one should be named, right? Naming again, right? Naming is hard. And then definitely rewrite it into a template string. I think it would be much more readable. At least I hope. Okay, why do I do it this way? I mean, this is stupid. I just now need to like add them together because both of them are strings. What did I do here? Why did I do it this way? But that was the name, and that's like the, I don't know, we can call it word. Save works, cool. That's definitely better. Maybe it's not, yeah, it's changed to whatever, split, cool, yeah, we have that, cool. That looks better, that looks better. This is what we want to do. Yeah, cool. I mean, this is good. I kind of like that. I will put here the examples. And again, as I see, if it starts with a vowel, you just keep it as it is. You don't do anything, just add AA, that's okay. If it starts with a consonant, like P, you switch it to the end. But the problem is that you don't care about letters, you care about sounds. And here, ch and chair is its own like a sound, right? So it needs to move together. The same with Q and queen, with queen, right? Okay, I don't know. We can look at how other people solve that. I'm kind of interested in that. Oh, sorry. I want to submit that. Pick Latin JS. I will copy this so you can see I'm posting the link to my solution, and let's see what others have. So I want other implementations of that. Let's see this one, and then I don't know, do we have something with comments or more iterations? Okay, this one, for example, I don't know, it doesn't matter. Okay. This is gonna be fun, so let's see that. So we have translate and underscore translate, that's bad. So this translate does exactly what we have. It just splits it into words and maps each word with this weird underscore translate method. And then it goes and it looks if it begins with a vowel. If yes, it returns a string here. Yeah. Otherwise, and that's gonna be difficult to read. So if it does not start with that, you take a letter. What? What is this? What do you mean by solve first? So it starts as a start, right? Okay, it's gonna be fun. This thing, and then you take. Oh, I see that. I don't like that. With any number of non-vowels, and then QU, or any number of. Oh, I see that. Okay. What do you mean? Before you see solutions, always solve yourself. That's what I did, didn't I? I'm okay. Hey, is this a JS stream? Yeah. Is this a JavaScript stream? We work on JavaScript tasks. So I guess yes. Okay, so here what they say, which is kind of weird, is that it's all the letters which are not vowels at the beginning, as much as you can take, form a sound. That's ambitious play. I'm not sure it works like that, and it doesn't say it in the documentation, right? And I don't know. I honestly don't know, but maybe it makes sense. And then you have the exception with Q and anything that's preceding that. I'm not. What is this? What? But it says you can have skew. Okay, I mean, this is exception, so you can have like. Okay, I don't think that's it. I don't know. I don't like it. Let's see the next solution. What they have here. He has. This guy has vowels. Okay. So again, we translate split, we have map, that's okay. We translate word, that's here. We do this dirty trick how to transform index of into Boolean, which I don't like. I mean, there are better ways, like wrapping in Boolean, or you're not using index of, but you could have use includes now. Is it include? Yeah, include. You can see that. Include? Yeah, includes. That's exactly it. It returns true. That's what we want. I mean, it will have this experimental flag, I think. It's not definitely supported everywhere. Oh, it's actually better than I thought. Yeah, that's kind of a good support. Yeah. Okay, so you can probably use that even like on your websites. Hi, Tadeusz. Yes, we work on these exorcism task called Katas, and we try to find functional solutions to it. Now we just finished this Piglet and we're looking at other people's solutions and we're comparing. We're looking at how they did that, and in a few minutes we will start with the next solution. Oh yeah, I see that. This guy looks very serious throwing errors. Yeah, he throws error. That's interesting. But let's go back. So this is he looks if it starts with a vowel. Okay. If he has, it's easy. Otherwise, he has, first vowel index. And then he slices like that. Okay, I see that. So maybe I did it wrong then. So, okay, this is not nice. This is not nice. So what do you do? But should be probably... What should be the solution is that you find the first vowel, but then you have these exceptions with the skew, right? And Q, because it's like it's these two sorry. Oh no, I did something wrong. These two are very different. Like if you have a CH and then QU, that's very different. Oh, because the key. Oh, okay. I'm not sure. I mean, there's another assumption how this should work. So you take all these, but if the preceding character was Q, you still count it, right? That's still very hacky. But I kind of see what they want to do. Yeah, that is, we could do that with every problem, but we want to write our own, right? And oh, funny thing. This is a funny thing. So I mean, Thaddeus wrote that we should solve it by writing import solution from npm whatever. But the funny thing is that if you look at npm and you look for like one of the most common tasks there are, that is a fizzbus. So you have fizzbus, like a package called fizzbus, and I am pretty sure. I mean, at least the last time I look at it, it was either wrong or pretty bad. Okay, I think it's here, right? I mean, he has so many things. Can you see that well? Okay. Okay, so this one actually works, but I think there was one solution called fizzbus which didn't work. Yeah, I mean, Q being example, I mean, yeah, sure, but you have to know that, right? I'm not sure. Maybe there's another, like a pair of consonant and vowel that forms a sound. Oh yeah, maybe it was like a fizzbus with a dash or something like that. I remember I was looking at these because we wanted to do the same thing, like import require and then use it, and it was wrong. And okay, I don't know. Maybe it was okay from the beginning. I don't know. Can we see the history of this file? I'm pretty sure there were like some problems with that before. No, okay, maybe on this one. Okay, whatever. Yeah, I mean, so you think the correct solution here would be to take consonants as long as you can, and if the last, like if the next one is, I mean, if the last consonant is Q and the next vowel is U, you take these together. Like that's okay. Here just used with Q, so it's a Q whatever E. He still uses that, which I'm not sure it makes sense. Like if you have Gue or whatever, it's not like this. It's just Q U. That's just the thing together. That kind of, I mean, that kind of makes sense. I'm not still like totally convinced about that. It would be better to like define it properly. Like what I did is I wrote these. Okay, I see that. Okay, I don't want to rewrite that now because no, I don't want to rewrite that. Or do you want to rewrite that? Like, is anyone like, do you want to rewrite it that it looks for the takes as much consonant as it can, does this weird thing with Q and U? I'm still convinced it actually works like that. I mean, I can't think of any words that would. Yeah, pass. I like that. Cool. Thank you. Pass. That means we can move to the next exercise. So this one is called, oh, Pythagorean Triplet. That's gonna be fun. Okay. Okay. I kind of think this is gonna be a heavy math thing. I mean, that's not bad, but I mean, sometimes it's difficult because, yeah, we'll see. Sometimes I want to draw when I want to write solutions for mathematical problems. Not sure if I will be able to do it here, but we will see. A Pythagorean triplet is a set of three natural numbers, a, b, c, for which a squared plus b squared is c squared. For example, yeah, 3, 4, and 5. Yeah, we know that. There exists exactly one Pythagorean triplet for which a plus b plus c is 1,000. Find the product of a, b, c. Okay, that's cool. So just for this thousands. Okay, let's look at the specification. That's the test, what we want to do. Okay, it's something different. But let's go. So we have this triplet, again, classes, stuff like that. We want to do sum, which is just summing these three numbers, whatever. Product, which is product of these three numbers, is Pythagorean true. Okay, that's cool. Oh, and this is gonna be fun. Triplet where max factor is 10. Okay. Triplet where min factor is 11 and max factor is 20. Okay, that's fun. And triplet where sum is 180 and max factor is 100. Okay. Oh, this is not going to be fun. This is not going to be that funny, I guess. Yeah, but let's see. Let's just write it as. Oh, and it says this. It has this really bad interface. If you see that this is a class, right? But this is not a class. It's like a static function on it. I don't like classes. I will not write it like this, but we can support that. But oh no, sorry. Yeah, it's triplet. It's the same. That's wrong. I don't know, like that. Whatever. So we need to support that, but first let's write an easy one. So we receive, how was that? Comma separated A, B, C numbers, and we will return this array. We have sum. Okay, I mean this is. I will change this to be sides. We have sum, which is a function that returns sides. What is that? Reduce with like summing. I will write that function soon, and we have the same thing for product, right? Sides reduce product. So that's kind of easy, I assume. So sum, click somewhere. So we get pref and next, and we return pref plus next. That's cool. And we have product, which is basically the same, but we multiply it together. Let's save that. Oh yeah. Calculates, okay, sided is not, why did I write sided? Sides. Save, works, cool. Product works. And we have a function is Pythagorean. Okay, that can be a little bit more interesting, I guess. Well, it's not, right? It definitely is not. So we write this function is Pythagorean. We pass the sides as an array. So we can destruct it here. So the only thing is that we want them to be sorted. We can look at that. I'm not sure if it will work right now. Let's assume they are sorted. And what you do is that you say, A squared plus B squared equals C squared. Save. Enable. We have that. We have that. Okay, so I mean, it's not sorted, but it doesn't like. For now, we can work with that, and it kind of passes. So here, C needs to be the biggest number of all of them. Okay, whatever. And now we have this really weird thing when we have to do this where, and we have to support max factor. like the you know, like the brand for mascara. Min factor and sum, and you can have two of those together. Okay. So I wanted to be smart about this, right? So what we could do, like the easiest thing, is to iterate min factor to max factor in 3 dimensions, check all the triplets, and return those that are true, and then and then filter those which have a sum of those, which is probably a solution. The problem is that we would have, like with this max factor, we would generate like 100 to the power of 3, a few million, right? It's a few. How much is that? Oh, wow, it's like to the 3. Yeah, 1 million exactly. Numbers, and we would check these, and as we see here, only 3 triplets are actually Pythagorean. So that would be a brute force solution. Okay, so this is a solution that would work, right? But we don't want to probably do that, I assume. So I think we can look at Wikipedia somewhere for some better solution. Like I remember there's this, we had it at school, like, how was this guy named? Like someone's like solution, and it said if you have r squared is equal to 2, how was that? Yeah. That it's true that r squared, which is equal to 2st, if you have these 3 numbers, then a defined as r plus s, what is this? I don't, then b can be defined as r plus t, and c can be defined r plus s plus t, something like this. I remember that right? But this is a Pythagorean triplet. And so the funny thing is that st, if I write it like this, it's clear that st is a factor of any factors of this. So maybe we could do actually this. We could go through even numbers, find the factors, yeah, I think it could work, right? So here what they say, okay, this is interesting. I will quickly check if this actually is true, and then I will probably implement that somehow, I guess. I can go to wiki triplet. I think I've seen that, yeah. Okay, can I, is it like a rule? No, where? Oh, generating a triplet could be, oh yeah, we have formulas for generating Pythagorean triplets, nice. Dixon, that's it, Dixon method, that's exactly it. Oh yeah, we have that. R squared is 2sta, remember that, yeah. My education is for something, I guess. Okay, I mean, this is gonna be so much math. I'm not sure I want to do that. Yeah. wrote it here, or I wrote it here. This is not going to be a funny solution, I guess. There's nothing like that. What I will do here is that I will have to name this somehow. Yeah, triplet. Let's go triplet. It's a bad name, but still. Export default triplet. And what we can do here, and that's the funny thing, is that we set triplet dot where is create or find triplets, right? Or generate, that's even better. Generate triplets. And we will write this function right here. Save. Cool. And we can enable, for example, this one. I'm not sure if it changes here. Sort of undefined. Oh yeah, whatever. So it returns an array is sorted. I know. Okay. Well, I don't know. Okay, let's do it for the max factor. So we have the max factor here. That kind of means, okay, let me copy that and write that. Can I copy this? Can I copy that? That would be cool. It would be so cool if I can copy that. Something almost, yeah. Oh, they have, okay, this is A. Maybe I should have done it differently. B, C. Okay, if this max factor, that's definitely going to be this one, right? Oh, and we know, let me write that R squared divided by 2 is equal ST. Like this. So we know that this needs to be smaller than this. So we kind of know that the R we will test needs to be like, I don't know, we can test it till the max factor, which is kind of maybe too much, but we can do that, right? We can do it from main factor. Okay, I can implement that, right? Oh no, let's do it later. Max factor. Check for these R's, there are, and then find the factors, which I think I wrote somewhere, and then check if they fulfill all the other, yeah, that all of them are max this, min that, and altogether they have the sum which we have here. Okay, I guess we can do that. So what I have is I will create an array of, I would say it's it's max factor divided at least, like, definitely, like, we can divide it by 2 by, like, with anything. Maybe it can be more, but we can see if it's actually slow. Let's go with this one. Then what we do is that we do fill, and let's call this fill, yeah, fill, so we can iterate it. Then we can map it, so we create a range, and here we do I times 2. Can we do that? Actually, it's I plus 1 because we don't want to start with 0, it doesn't make sense. So we start with 2 because you see this needs to be an even number, right? So we do this, let's format that correctly. Now we have that. And now we will generate we will find the factors. This is gonna be so annoying, but okay. We map each, and this is gonna be the R we have. We will map it into R squared divided by 2. We don't have to have these, right? That's like, oh no, but we need to keep the original R, so we do it like R, comma, I don't know. Okay. And now what we can do is, no, okay, let's not do this. Let's not do this. Let's just map each R to, how to name this? Okay, let me go back. We have this thing, right? And what we want now is that we have R and then, what is this? N. And what we do actually, we still want the R and we want, this is bad, this is bad. Oh yeah, we want to have all the factors of this number, of this n. And then we do something else, I don't know. Yeah, we have all the factors, so let's do that. I'm sorry, yeah, we can do that. I so don't like this. So we find, okay, let's do it. We have factors of n, and we will map them such that we have a factor f, and we return a triplet. F n divided by f, which we know is a number, and R. Yeah, that's it. Okay. So we have these three, and then what we can do is we will flatten them, and that's all what I want to do now. So flatten is pref, comma, next, return, pref, concat, next. That's it. That's all we want to do. Oh, it's const. This is not fun. This is not so fun. I mean, if you guys weren't here, I probably wouldn't do this. But maybe it's good we try that. Unexpected token. Wow, what's happening? Where? Oh, too many. Oh, we have this map here, and then we have this map here. That should work. What is the problem here again? What expected? 15, 18. Where's that? Oh yeah, sorry. We need to wrap these into brackets. Save, cool. Yeah, at least it does something. Whew. And we don't have the method factors. That's the next one we're going to write. Don't we have it somewhere? So we get number n, and we want to find factors. I think that I wrote it, so I will look it. Oh, okay, I see I have write that. All factors. That's it. Okay, I will use this method I wrote somewhere in the past. I'm not sure though if it's not too many of them, but it doesn't matter right now, I guess, right? It's called all factors. Well, can't read property sort of undefined. What do you mean by that? So what do they do here? We are here. It should return an array, right? This still should be an array. Oh, we don't return that. Okay. Yeah, triplet.product is not a function. Okay. Because we need to, what we need to do, okay, I need to put this before that, is we need to actually return this thing. So we need to map that into triplet. Yeah. So what we have here, we have the sides, and we need to transform it into triplet sides. Save. Okay, so it seems that we return too many of them. Oh yeah, of course, because it's still possible we went over this max factor. So can I somehow, yeah. So what I want to do is, when I have this flattened, I want to console log that. Candidates, where is that? Candidates. And I want to see where we are here. Yeah. What is max factor, by the way? Max factor is okay. Yeah, I see we have like the 18 here and 42, which I'm not sure how we got there. Oh yeah, it could have been bigger. And then we have these two are different, right? But they are not, right? Okay, I see that. Yeah, that's a problem. The same goes with this one, and this one is the same. This one is the same, and these two are the same. And this is not actually a valid triangle, right? Okay, I see that. Okay, we need to, like, with these candidates, we still have to do a lot of things, right? So what we should do is that we should sort it. The problem is that the default sorting in JavaScript is lexicographical. It means it doesn't work as we want it. Where am I now? So yeah, we need to do B minus A. So now it should be sorted. Well, can it isn't defined? Why isn't it defined? Oh, it's candidates. Candidates. Save. I'm sorry, this is not fun, is it? And we have here. Okay, yeah, it's still. Where's the console log here? Oh, here, yeah. Is it? Oh, and we want to actually we want to sort it the other way around. That is nice. Now it's sorted. Yeah, the biggest are here. And now what we can do, we can also filter. We will do multiple filters. So first what we do is that size dot, is it each? I always think it's each or every. So each s is smaller or equal to max factor. That's one. That should like okay, so it's every. Yeah, it's every. Okay, that removes those. Is it up to 10? I'm not sure if it includes that. Maybe it's smaller. Yeah, that looks better. That's one problem we have. The second one is that we have duplications. This is duplication. This is a duplication. This is a duplication. This is a duplication. This is a duplication. And this is not actually a Pythagorean triangle. I'm not sure why it's there actually. Maybe this one needs to be a little bit more than one. We can do this like this. Yeah, that looks better. Does it include the... Okay, oh yeah, we did something wrong. Maybe you can actually start with 0, I don't know. Can you? No, it's the same. But the problem I have here is it does not include the most famous one, like 3, 4, 5, right? And that one is definitely a... Okay, this is not fun. I need to consult Wikipedia, but yeah, all Pythagorean triplets may be found by this method. Oh, you say any of these doesn't look Pythagorean? Yeah, that's true maybe, right? Oh yes, of course. We do so, oh man, because we want to do r plus s. Okay, yeah, you are so right, you are so right. So, very good observation. I'm stupid about this, yeah. So what we actually want to do here is we want to do more of those, right? We get a factor, but that's what we want. We want these, this is the s and t, so we want these, both of those factors. So we take factor and we turn it into f and divided by f. So it's like these two together create this number which we want. And now when we have them, we can call them s and t. We can actually do what we want. It's r plus s, r plus t, and r plus s plus t. Oh, that is good. Thank you. I think that's at least, okay, I was wrong. What did I have wrong? Oh yeah, again, I forgot to put the parentheses around these. That's safe. Okay, oh yeah, that's much better. Now we and we only actually have one array, which is wrong. So we somehow remove it. If I do this, we have 3. How many do we want? We want 2. How is it possible? Oh yeah, and now it works, but we had the duplication. The problem here is that with the function all factors returns all factors. So for example, for the, yeah, this is good, this is good. But we have it twice, right, here. Is there a way to remove that? Is there a simple way how to not include the second one? So yeah, I know we could have written this as a recursive function. Yeah, if you do it as a recursive function, then we can like only do the next one. Yeah, okay, we can do that. Okay, let's do that. So let's keep this, let's call it all captors blah 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 22. Let's create a new function which is going to be a recursive function. So we have the n, we need the n, then we have the factors we have, and then we have I, which is the number we want to test for. The factors is by default empty, and the first I we will test for is, well, one is kind of there, right? But we still like, one will always be a factor. That's important to have. Yeah, sure, it will always work, I guess, yeah. And when we have this, so if n is bigger than I, return factors. So that's the end condition. Otherwise, you look if n divided by I is 0. If no, return, oh yeah, return all factors n factors I plus 1. So we go to the next one. If it is, you take all factors of n divided by I, that's just the rest of that. Here you do factors and you add the I and you test with I plus 1, because I mean we don't want the multiple factors if it's still true, right? We don't care about that. This could work. Let's save it. Yeah, we run to the problem of maximum call stack, which shouldn't be a problem, but we kind of think we know about this, right? So what we do here is that we write a node with harmony flag to enable proper tail calls, and we do bin, oh no, node modules, oh, come on, node modules dot bin jest watch. I hope it's like that. And it still fails. It still has maximum. Well, that's not how it should work. This should be a proper tail call position. And it's, I mean, we go from n till something. Maybe we have this problem here. No. And it's always bigger than I, right? Okay, now we have something. Now we have everything doubled. That is not fun. Okay, I will again. Where is the console log? Yeah, here. Yeah, so we have everything twice. Because we get this triplet, oh yeah, this factor, and this factor. That kind of means we will always what we can do is that if we know this is divide, yeah. we can change that. Maybe we can change that. I'm not sure about that. Maybe this can be actually this can be simple. I don't know. But we can actually change. We can divide with the other one. No, still a problem. Oh yeah, it will be always a. Oh man. Can I get? Okay, so this first one is a triplet, right? But that's because I think we start with I 0. Yeah, that kind of solved that. And now we have that, but we have everything twice. And we will have everything twice. I thought we could get rid of that this way, but we actually, okay, I see that. I see that. So if I divided by I is 0, and that's going to be it. Factors dot includes n divided by I. So if we have the other factor, like the other from the pair of factors, we don't include it. Yes, cool. That was easy. I mean, not that easy. Yeah, I know. I mean, I will probably keep this. I will keep this. I will still do this because we just implemented a max factor. Now I want to implement this min factor, right? We obviously don't use it, so let's do it alphabetically. Min factor is 0 by default if it's not implemented. And what we can do, I mean, there are two options. We either filter it again. Yeah, I think we have to. I mean, otherwise, I don't want to get into this math when something can happen. So what we do is that every s is, and I'm not sure if it's at least that, or I mean, I'm not sure if it's equal or not. So I will save this and we will see. It's like that. That's cool. And now we have this sum, right? So you always have to have this max factor. If you don't have it, it will fail. And now the sum is actually easy because we do the same thing, but we check if the yeah, where is that? Sum. And we want to do it if it's defined. Yes. Yes. So we can do, I will move this here, and now what I will do, okay, if sum is defined, then what we will do, and I will rename this to triplets. So if we have sum, we take the triplets and we filter them one more. And the good thing here is that we have this function called sum. So we can have a triplet to triplet dot sum equals sum. Oh, I'm skipping that test. No, why? Oh yeah, we need to return that. No. Okay, we have something here. We don't get all of them. Okay, maybe I can skip this. It still doesn't help me. That's weird. Okay. So it's difficult now to say what is the problem, right? Because we are missing something. But Yeah, but still, I mean, this should like produce more of them, right? Do I miss something? So max factor is 100 and the sum is 180. Oh, it's a product. Man. Oh, it's always a product. But that kind of means that divided by 3. Oh, no. Can I do like a first square? Like something like this? Can I do that? Is it possible? Is it possible? How do you do okay. Yeah, okay, I didn't write it right. Oh, okay, yeah, it's first root, I'm bad. 58. Okay, so that should be actually possible. So the question is, do we so we take the triplet and only those who have the sum equal to sum. Does anybody see something? I don't. I do not. Let's finish this. I mean, it's kind of nasty they didn't show us the solution, like without the triplets. Oh, we can do that, right? No, we can't. The product kind of removes that. Yeah, we still do max. So you see the max factor is like the biggest R, and this R is here, right? So all of them will be like, if this is 100, all of these can be potentially, or can be potentially more than 100. So we do take all of them, right? This takes all the factors. I kind of think that maybe I should like, oh no, I will console log those triplets. Okay, I don't know why it's like this. And that's one thing. And the other thing is that I will only run this test so it's easier. Oh yeah. Just like for now. Oh, okay. Still, yeah. So now we can see all of them, right? Before they are filtered. And we can also map T to the array of T, comma, T reduce sum. I mean, not that nice, but it works. No, it does not. Oh, I will do this. I know it's not good, but I will just do it now because I can't remember. Triplet product is not a function. What? Oh, it's bad. And we want those at 180 as this one, and that's it. Do we miss something? Maybe we do. I don't know. Can I put like +1 or something? I don't know. It should still not. We're missing 2 of them. That seems to be too much. This one is 182. This is weird. This is really weird. What they say on Wikipedia is they say it's all Pythagorean triplets may be found by this method. That's important. Like, that means we are not missing anything here. We are not missing anything. So I mean, I see this one, right? That one is 180 definitely. Well, I mean, this okay. I think that maybe we can see that, right? I will try this. So is it important? I mean, can it be like, I mean, this max factor is kind of limited either way, right? I mean, if I put it like max factor times 2 or whatever is that, don't filter that, and just look 4 of them where there's 180, it's still like this one only. It can't be much more, right? So I will actually, I mean, this is not cheating, it's just like I want to make sure what is the solution. I'm not sure if it will understand this. But maybe we can see why we are missing these in here. Do we like, no. At least if we know the solutions, like for which are we missing, right? And how is it possible we miss that? Okay, I mean this is kind of desperate. We should like link to this Dixon formula and this before this, so people know what we are using, right? Otherwise it could be pretty confusing. I guess this one doesn't understand what I want to ask, like what I want of him. Okay, let's go through that again. We go like from we go only by, oh yeah. Could this be a problem, like because we only go through? Okay, let's try this. No, I mean, we still generate a, okay, we have this one, and that's still the very same we had before, isn't it? Yeah, this doesn't, oh, is it possible that it's, no. It needs to be only even numbers. I mean, otherwise this can't be. Yeah, you can't divide it by 2, right? It would be not whole number, and then we can factor that. So that's why I can do like these 2, and it will not change anything. Yeah, it's the same. Okay, yeah, cool. Okay, what I will do is that I will remove this. We get really big numbers here, okay, but it still doesn't generate these these 2. That's kind of sneaky, I guess. We don't get anything like close to that. Yeah, that's the one we know about. Okay, so this one is not actually, it's actually K. I just like looking if it doesn't like filter more than we want, oh, this one, I kind of, everything is, oh. Why is it wrong? I mean, are they sure it's correct? That doesn't do anything. This is, so is it possible that we are missing some factor? Okay, let's see that. We start with factor 1. That's definitely always oh. Yeah, so it all means that if so S is 1 and T is R is always a valid solution, like always. That's interesting to know, but that kind of follows the formula of how you write that, right? So we start with 1 and then we do the 2, right? If I divides n, this divides it, and factors does not already include this. Okay, I will do this just for the sake of maybe removing. Oh, haha. Okay, so we did filter out the solution by this. How is that? We have this 180 here, 45, 60, 75. Okay, that is interesting. 18, 80, 82. And where's the third one? And this one. Okay, that is weird. So this actually does remove a solution. Okay, that means, I'm not going. Yeah. What is the problem here? So first, I want to remove this console log, I guess. Run pay 24 triplet. Why is it not a function? Oh, I was refactoring and forgot to move it back. Save. Yeah, and now we have the problem that this can actually include two same triplets. I don't understand how this could work. Like, if we have the other pair already in the factors, right? That kind of means that it has to be there. Maybe I'm missing something. What did I write there? Okay, shouldn't have it like this. Okay. So this one belongs here. So now we are very close to the solution. Oh. Wrong one. Yeah, so now what I'm actually very interested in that is to see where this goes wrong. I should not have, yeah, okay. Why do I do this? Why do I do this? Yeah, like this, right? So what I have here, I just want to run yeah, it takes this away. So let's find out what is the, can I find that actually? R as T. Yeah, I can, right? So this is R plus S, R plus T, R as T. So it means that if I, yeah, so T is 75 minus 45, that's here, that is 30. That means that S is 75 minus 60, that is 75, right, right there, before. That is 15, and that means R is 45 minus 15, that is 30, right? So if 40, yeah, 45, 60, 75. So we want all factors of number 30. No, sorry, of this number for 30, okay. So I want console log for 30 to the power of 2 divided by, oh man, divided by 2. Oh, 1, 5, 3, 5, 15. And that's when this thing is okay, I will copy that. And then when I enable this, we are missing the 15, right? Is it no difference? Okay, I copy that. So is this one versus this one. I'm not sure why is that like that. Why is the 15 missing? And by the way, what is 30 to the power of 2 divided by 2 is 450. Okay. The whole thing divided by 15 is 30. Okay. Then I'm not sure how this actually, oh, I know. Because if I do this, I should not do this thing then. Okay, no. So, I don't know. I'm removing this thing. Putting this here. And I will probably make this function and we'll take it and we'll put it into these pairs and just keep the ones that are not there. I don't know, can I do that somehow easily? Can I somehow remove those? Can I somehow easily remove duplicates of arrays? I guess I cannot, right? Yeah, that's the very last thing missing. Remove duplicates of either pairs or triplets. Oh, I know what we can do. Okay. Oh. I hate this. I hate this. Removing duplicates is difficult. I think we should do it here. Like here, we should remove, or can we do it here? Maybe that can be kind of smarter. So the problem was, if you remember that, is that if I have like number like 450, right? Then the factors include 2, it includes whatever, I don't know, 3, and includes 5. And then when I want to include 15, I actually do it with number 30. This factor is already there, so I can't do that. I mean, it can still be there. But I don't want to include the number 30 again, because, okay, so what I have here, 2 to 5. And I want to remove either this one or this one. Does it mean that if I have all of them, can I take just the first? Hi Slurdarth, welcome. No, I mean, the problem here is, okay, and it's 150. So you get something like this, right? The problem is that this together, okay, sorry. Oh no, man, but if I have 450 divided by 5, it's 90. So I think it looks like this. The problem is that this one is like here with this one. This one is this one, like they make pairs, which actually, I can take the first half. I can take the first half here. Okay, I'm pretty sure now I can take the first half. Because these are together, these are together, these are together. Okay, yeah, I will try that. Okay, take half, that's nice. Half. Yeah, I have to do it somehow. I will create a function for that. Const take half. It receives an array, and what you do is that you do array dot slice or spice. Slice, and we want to take 0 to half, yeah, beginning, end. So we take 0 till array dot length divided by 2 minus 1 maybe, which we will see in a second, guess. Oh, that is good. No, it's not excluding number itself. Sorry, where is that? So, okay, so what I wanted to have here is that you have that if factors already include includes n divided by e. I still think that should work, right? Okay, now yeah. What was wrong here? Factors includes n divided by e. What is the problem here? I'm stupid, I guess. I don't see something. Yeah, I mean, why doesn't it work? Yeah, sorry. Now I can't take the half, right? That's the problem. What? I definitely had that. Did they do something different? Okay, I don't know. Oh, I know. I here had this like. Yeah, yeah, that's it. We want. It's okay. This is exactly what we want. And n not equals I. I guess it's okay because we already have one there, so it will not be included. We have it like by default. I would say I had this. How is it possible? Would I like? Okay, that was a weird mistake here. I will save this. I will check that I have all the tests enabled. Cool, and I will go through the solution one last time, and I will submit it. So let's see. So we have this. First thing is that we have this triplet thing, which receives sides, and it provides some product, and it's Pythagorean. It just like runs that. So it's pretty easy. We can put these. Yeah, this one should be somewhere here. It's like these are like helpful functions you can reuse, which is good, and I've been reusing them a lot. Then this is like what we want to write. That's kind of easy. Just test this condition. It's straightforward, and that's what we have here. And then we have this generate triplet, which can receive, and this is kind of long, so I will. Yeah, and I can write it as it's supposed to be, like this. What we do is we take the triplets, we generate triplets. Maybe this is not optimal condition. When I look at it, you know, we will have this, so we want this to be. No, I mean, it's pretty weird. R needs definitely to be smaller than. I'll just keep it as it is. I mean, I'm pretty sure this could be something smaller. It can be smaller. I'm not really sure. Like, there's some weird maths in here. I don't know how much you can go, but this should work. And you take it. You only go through even numbers, starting by 2. And you have this pair, you need to remember the R, and then you have this number, which is magical in this Dixon method. And then we create the vectors for this number. We create the pairs of those vectors, and we generate the triplet as defined by this method. That's cool. We flatten it because this will create array of arrays, but we only want to have, it will be arrays of arrays of arrays, but we want to only have array of arrays. Then we filter those that have a side which is bigger than the max vector. We filter those that have a min factor, or a side smaller than min factor. Then we sort it. We don't have to do that, right? We don't have to do that. Okay, okay, that's cool. So we create these triplets. So it has this product function, and then if a sum is provided, we filter it again. Okay, we can change that. What I will do here is that I will change that, and that's gonna be actually funny because that means we don't need any of these. So it can be like this, cool. And what we do here is that if sum is provided, we do this, otherwise true. We can write it as, so if sum, so it's not sum, or this thing. I mean, that's not very readable, I would say. That's a bit hacky, right? But it does what you want to do. So if that's a bit cool. Sum is not undefined. Yeah, okay, let's not do that. So not sum or this. That's cool. Yeah, we have it. Like If you remember the name of the stream, it's called map, filter, reduce. We have map, 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 reduce, filter, filter, map, filter. That's it. That's exactly what we want to have. I like this. I mean, I really like how this goes because it's very easy to follow each step, and it's so easy to know what's happening. It's really cool. I mean, that's what I love about this. This is what I love about this. Okay, guys, I guess this is what we can submit. It has taken me more than I thought. It's almost an hour for this task. I don't like that. So, Recursive, submit, Pythagorean Triplet JS. Yeah, thank you, Honvid. Yeah, thank you very much. I also think it's very well nicely done. I like this generation, but it was pain in the it was really pain in the let's quickly see the solutions. I mean, if I now find out there is a simple solution for this, I will be angry. Okay, who? Good. This person doesn't have it. So so the difficult part here is the generation, and what they do is that they have this triple iteration in itself. That's definitely not nice. That was the first idea I had. On the end, it's like, I don't know, 7 lines. Maybe it would be easier. So this solution creates a bunch of triplets, like all of the triplets, all of them with these conditions. It could be like thousands of them, and then they filter it. Okay. This one is the same. Okay. So I kind of think that, yeah, it's the very same again. Yeah. that is interesting. That's funny. Okay. So I think we found an original solution to this. It's rather long, right? Not that long. How much is that? It's like 15. I mean, that's not the part. Like, this is the important file. So it's like 12 lines. I think it's kind of okay, and I think it's actually, if we work on this, if we find out what is the actual number, like the biggest R we want to test for this to be smaller than the max factor, it could have been even more performant. But even with this, it's pretty good. We just go through it. We create the factors. We don't. Yeah, I think this is good. This is good. We don't do thousands. We definitely don't do thousands. I mean, we do this map is the max factor divided by 4. So that's like in this biggest case, it's 25. And then for each factor, how many factors can a number have? I don't know. It can be like, I mean, this is a big one, right? But still, it can be 5 or maybe 10 if you go with 10. But it's okay. Let's be precise. 25 times 25 divided by 2 is 314. Yeah. So the biggest can be, I think it can be more than 5 or 6. I would say 6. So it's 6 times 25 times 6. So at the most we do 150 iterations. Like, we test only 150 combinations. That's definitely not much. That's really cool. I think that's much better than what they have. Oh, that was interesting. That was really interesting, I must say. So guys, that was really fun. It took a little longer than I expected, but this last solution, I'm so happy that we finally finished that. I mean, if you weren't here, I probably would have given that up, but you were here, and I was able to do that. So thank you very much for that. Thank you for your comments and your suggestions. I enjoyed that again. It's cool. If you think that you will find out something later, just write me. You can follow me on Twitter or here on Twitch. And I would be very grateful if you could give me some comments about how you like this session, and if you want something else, what is that, or general comments on that. I'm thinking about doing a session this Wednesday or Thursday, but I can't promise that because we might have some work stuff. So I'm not sure. So I will try to do that. I will let you know definitely on some of the channels. But I really like these. Okay, good night and enjoy your day.